Autophagy is like the ultimate behind-the-scenes manager in your cells, a microscopic janitorial team tirelessly sweeping through your cytoplasm, dismantling broken mitochondria, misfolded proteins, and other cellular debris, then recycling it into reusable building blocks. This is the kind of efficiency that would make even the most obsessive office manager envious. The catch, of course, is that autophagy thrives during fasting. Once breakfast arrives, be it eggs, oatmeal, or a smoothie, insulin spikes, and TOR pathways light up, and your janitorial crew reluctantly hangs up their brooms. Lysosomes sigh, proteasomes roll their metaphorical eyes, and AMPK mutters, "Really? We were just getting into the rhythm." Here's where it gets both scientifically fascinating and humorously ironic. While fasting promotes autophagy and long-term cellular cleanup, breakfast promotes immediate cognitive alertness. The brain is an energy hog, consuming roughly 20% of the body's daily glucose, and it demands fuel first thing in the morning. A high-protein, balanced breakfast spikes glucose modestly and provides amino acids, feeding neurotransmitter production, supporting synaptic plasticity, and improving attention, memory, and mood. In other words, breakfast temporarily pauses the janitorial work in favor of activating the executive office of the body, the brain. Autophagy may sigh in the corner, but neurons are firing happily, ready to handle emails, meetings, or maybe just the existential dread of Monday morning. Fasted states, in contrast, activate AMPK and suppress mTOR, signaling autophagy to sweep the cell with precision. Damaged mitochondria are recycled, misfolded proteins are dismantled, and lipophagy mobilizes fat stores, improving energy flexibility. But the brain may feel slightly foggy because glucose isn't immediately abundant. Alertness, focus, and mental performance are not fully optimized in the early hours of a fast. Your cells are having a spa day while your neurons grumble. Hello? We need some coffee, or at least some glucose, to start functioning. It's a humorous tug-of-war between long-term cellular maintenance and short-term brain performance. The comedy of this scenario is almost cartoonish. Imagine lysosomes armed with tiny brooms, scrubbing the cytoplasm with meticulous focus. YMPK waves a tiny flag, shouting, "Today is deep cleaning day." Suddenly, breakfast bursts in, led by insulin in a neon vest, waving glucose packets like confetti. Hold it. Nutrients detected. Brain fuel first, cleaning second. Lysosomes groan. Mitochondria fist pump the incoming energy, and neurons do a happy dance as neurotransmitters surge. It's a molecular sitcom. Autophagy wants order and long-term maintenance, while breakfast and cognitive demand pull attention toward immediate performance. Scientific studies illustrate this trade-off clearly. Intermittent fasting or delayed breakfast enhances autophagy in multiple tissues, including the brain, liver, and muscle, supporting mitochondrial efficiency, protein quality control, and overall cellular resilience. Meanwhile, early feeding improves working memory, reaction time, and cognitive alertness, especially crucial for adults starting busy days or students tackling early morning exams. The tension between these outcomes is not a flaw, but a feature of human evolution, allowing the body to balance long-term cellular health with immediate survival and functionality. A practical takeaway is that timing and context matter. For someone focused on cellular repair, delaying breakfast by a few hours allows autophagy to maximize its effects. For someone needing peak mental performance immediately, a modest breakfast ensures cognitive alertness while still allowing autophagy to resume later in the morning or afternoon. Nutrient composition can also modulate this balance. Higher protein, lower carb breakfasts may modestly limit autophagy without sacrificing too much alertness, whereas sugary, high-carb meals provide rapid brain fuel but strongly suppress cellular cleanup. The positive and funny spin is that your body orchestrates this trade-off with remarkable finesse. Autophagy and brain function may have slightly conflicting priorities, but the system adapts seamlessly. Lysosomes may grumble, mitochondria may cheer, neurons may do backflips, and insulin may burst in dramatically, but everything ultimately works in concert. You get the best of both worlds. Your cells get repaired, your fat is mobilized, and your brain gets the fuel it needs to think, move, and maybe even appreciate the tiny molecular comedy unfolding inside you. Ultimately, The fasting autophagy versus breakfast cognitive alertness paradox is a delightful example of how human physiology balances long-term repair with short-term performance. Skipping or delaying breakfast enhances autophagy and cellular cleanup, improving resilience, energy efficiency, and potentially longevity. Eating breakfast ensures that your brain wakes up and functions optimally, ready to tackle the day's challenges. The system is clever, adaptable, and, if you imagine it right, hilariously dramatic. Lysosomes scrubbing, neurons firing, insulin bursting in with a clipboard, and mitochondria fist-pumping to keep everything running smoothly. It's biology with a sense of humor and a plan for your long-term health.